The first topic being TRIZ for Breakthrough Cost Reduction by Dr. Alex Lubermisky. Just a little bit about him. Dr. Alex Lubermisky has about 30 years of experience in in-depth research and development for the theory of inventive problem solving, value engineering, innovative technology of design, TRIZ Plus, and the most recent, Gen 3s. He was the major contributor and developer of such post-TRIZ tools such as function analysis, trimming, feature transfer, S-curve analysis, evolutionary trends, so on and so forth. Over the years, Mr. Lubermisky has led mentorship and facilitation programs for a number of Fortune 500 companies such as General Electric, Intel, Siemens, British American Tobacco, Alcoa, Wrigley, etc. in countries like United States, Germany, UK, China, South Korea, Colombia. Since 1983, Mr. Lubermisky has trained thousands of people to become innovation professionals. He's the lead instructor for seminars that grant Mastery's Level 3 certification, that is the highest level of learning in TRIZ. Henrik Altschuler, the founder of TRIZ, awarded Mr. Lubermisky with his certification for TRIZ Master. Mr. Lubermisky is the founder and co-creators of the TRIZ methods. He's also the author of more than 20 patents and multiple publications. He's also the member of TRIZ Master Certification Board, Methodical Expertise Board, and Editorial Board of TRIZ Journal. Mr. Alex, we welcome you to the dais.
Just once again, Alex Lubermisky, please Alex, okay? Today I'm going to present to you one of kind of our developments, TRIZ for cost reduction. Because you know, cost reduction, it is very kind of typical project goal. And in general, we have the same kind of structure of project. Project structure is the same, but there are some nuances. We can adjust our projects for different purposes. For example, if you need to increase functionality, okay, we know how to increase functionality. If you need to reduce cost, we will reduce. If you need to make a long-term forecast, we will use the same tools, but with some adjustments. And later on, we will discuss how to make long-term forecast using our methodology. But now we will discuss how to reduce cost dramatically. Okay? What I'm going to tell you, just major tools we usually use for cost reduction, and I will illustrate discuss some of them, and we will have some kind of case study. I will illustrate these tools with some examples how we reduced cost in different areas. Let's start from very beginning, from background. Well, you know that there are different sources of cost. Why our products, our services, and our technologies are so costly, so expensive? Because there are a number of sources, you know, capital cost, labor cost, and so on. There are a number of sources of cost, and in general, people are well aware about these sources. But what people less aware, that there are different stages of life cycle, because usually we focus on operation, right? You take the product and look how it operates and think why it's so expensive. But guys, there are other stages of life cycle. For example, you know, packaging, transportation, storage, and usually people do not pay attention to it. And in most cases, you cannot do anything on the operational stage. Your product is perfect here. But you can reduce cost dramatically if you think, how are you going to fix, to repair this product? How are we going to utilize this product? There, we can reduce cost dramatically, and usually people don't pay attention there. Okay? And there are a number of methods how to reduce cost. Guys, we are not first here, because it's so important that people develop a lot of methods, and they're effective. You know, no critics. For example, lean, or derivative of this lean, Kaizen. There are different cost reduction techniques and methods. I think lean is rather organizational method rather than methodology, because it doesn't have a lot of tools, but it is well organized. That is why we can observe a good results here. But you know what? We believe that our method is better. Or I would say it is complementary. It is complementary with all other methods because we can use this organizational structure of Six Sigma, of Lean, and introduce our tools because the core competence of us is methodology. Step-by-step methodology, instruction. It is pure rational, no irrational steps. You know, no, oh, think out of the box. No way. Number of algorithms included one inside another. Okay? Major tools. First of all, MPV discovery. What is MPV? MPV is main parameters of value. These are parameters of your product or technology or service which could affect purchasing decision. Because guys, theoretically, you can improve number of parameters of your product. But people are not ready to pay for all of them. They could ask you to improve, but they will not pay for it. That is why we need to identify only that parameters that could affect purchasing decision and improve only them. Because remember, our ultimate goal not to improve mankind, but to get money. That's why we need to improve parameters people ready to pay for. Okay. Also, we use cause and effect chain analysis because actually our major tool is function analysis. We just take our product or technology, doesn't matter, divide to components and analyze functions. And there are a lot of functions and there are a lot of disadvantages associated with these functions. There are harmful functions and sufficiently perform useful functions. And because all of them, we have excessive cost. But does it mean that we need to address all these disadvantages? Theoretically, we can do it. We have very powerful problem-solving tools. But you will have number of solutions. After that, it will be necessary to coordinate these solutions because sometimes they contradict to each other. And it will be very kind of excessive effort. And we have a contradiction, right? If you address a few disadvantages, you will have reasonable effort, but you will improve your system insignificantly. And vice versa. If you address all of them, you will improve your system, reduce cost dramatically, but you will spend a lot of time and effort. And beauty of our methodology is it is self-applicable. We can apply TRIZ to improve TRIZ. And we resolve this contradiction using cause and effect chain analysis. You know, the good news that these disadvantages are not independent. They depend to each other. And we can organize them in form of cause and effect chain and address only key disadvantage. In this case, entire structure will collapse and we will significantly improve our system and reduce cost dramatically without excessive effort. And of course, it is not approach, it is a tool. There are rules how to build cause and effect chain, how to identify key disadvantages. We have software which supports this type of activity. Okay. Also trimming. Trimming, it is our kind of core competence. Because you know how usually people used to improve these systems. We used to add some components, right? You need to heat something, you add heater, right? You need to cool something, you add cooler. You need to support something, you add supporter. And you add and add and add, and your system becomes, you know, larger and larger and more expensive. And we apply very counterintuitive methodology. We decided, no, vice versa. Let's eliminate as many components as possible from the system. By the way, what components? Of course, first of all, we need to remove components responsible for key disadvantages we identified during cause and effect chain analysis, right? And because sometimes we don't need to address the disadvantage. Let's eliminate component responsible for it, and disadvantage will disappear without problem solving. But we cannot just eliminate components like that because components have useful functions. Let's delegate these useful functions to other components of system or supersystem. Or in this case, from function point of view, our system will work well. But from cost reduction point of view, it will be much cheaper because we will not have all these disadvantages. And of course, it is not approach, it is technique. We have rules, separate rules for trimming of products, separate rules for trimming of processes, some recommendations. What is beauty of this technology? It is teachable because it is rational. We can teach people. And of course, we have software for this purpose. Feature transfer, another very powerful tool. Because, our informal kind of motto of our company is we are lazy. We don't like to solve a lot of difficult problems. We prefer to solve few easy problems. And idea behind feature transfer is very simple. You have a problem. But probably somebody somewhere already solved this problem. And we need just to find this solution. How to do it? Let's find a system which doesn't have disadvantage your system has. What does it mean system doesn't have this disadvantage? It means that somewhere inside there is a feature which allows that system to be so good. And let's find this system. Let's identify what feature allows the system to be so good and transfer this feature to our system. In this case, you will need to solve just adaptation problem, and that's it. Okay? Extremely powerful tool. It could be used for different purposes, particularly for cost reduction. And of course, trends of engineering system evolution. It is basis of all our methodology. What are these trends? Actually, it's not kind of easy to accept the idea that somebody could dictate you how to make your system. It's my system, right? I can make it white, I can make it black. Who can enforce me to do something? It's true. I can do anything I want. But after that, my product or your product will go to the market, and these products will compete to each other. And this competition is quite Darwinian. Some products survive and occupy large market niches, and some products die out. And we decided to extract and describe typical features of winners, of evolutionary winners. And systems are very different, but problems they meet are similar. Similar problems mean similar solutions. Similar solutions mean similar feature. We describe them in form of evolutionary lines. And using these trends of engineering system evolution, you can improve your system dramatically, particularly you can reduce cost. Guys, we cannot promise that if you follow these trends, your system will win. But probability of success will be higher. Clear? Another tool, function-oriented search. It is even more precise than feature transfer. Because when we apply feature transfer, we just transfer feature, right? But function-oriented search provides us exact solution, just existing solution, existing technology. But guys, it doesn't make sense to try to identify such solution in your area because you are good experts. If you would have such solution in your area, you would already use it, right? But how to find solution in remote area? You are not experts there. And there are thousands of them. And we have special techniques called function-oriented search. First of all, we formulate problem in form of function, how to heat water, how to move something, right? And after that, we need to identify so-called leading area. It is area where this function is vitally important. For you, it's nice to have. But for them, it is kind of a question of life or death. And probably they know how to do it because otherwise they would not survive. Let's identify this area. Let's identify solution from there and just adapt it for your system. It's very effective tool. It's we are a consulting company. It's our preferable tool. We claim that we are good inventors, but we don't like to invent. We just try to find existing solutions and just adapt them. Okay? And now I would like to illustrate these tools because I just provided you a brief description, but abstract description is nothing without illustrations. Let's start from cause and effect chain analysis. This is definition of cause and effect chain analysis. We are going to build this chain of disadvantages and identify key disadvantages to be addressed. And it was a real project many years ago. I personally was involved in this project. We performed it for Procter & Gamble. You know, in that time, marketing people identified three groups of coffee drinkers. One group didn't care about aroma and taste, and they used to drink instant coffee. They call it coffee. Second group understands what is real coffee, and they used to boil it manually. And that time, by the way, it was many years ago, there were no good coffee machines. And they identified a third group. First of all, these guys like real coffee, but they don't have time to boil it. And to satisfy this group of customers, they developed so-called coffee bag. It's like tea bag, but you know, paper bag with ground coffee. And idea was, oh, let's put it to the hot water, move it like that, or you have coffee. For marketing people, it was end of the story. For engineers, it was nightmare. Because I hope you understand, if you put this bag to hot water and dunk it like that, what you will have? Will you have coffee? You will have like yellow water. After that, they decided, okay, let's add more ground coffee. Okay, instead of yellow water, you will have brown water. But still, it is not a coffee. After that, they decided to cheat. They decided to add some instant coffee there. In this case, you put it, it will be black, and after that, but first of all, instant coffee is very expensive. Plus excessive amount of ground coffee, too expensive. And remember, this group of people just hate taste of instant coffee. And that is why they asked us, guys, do something. And it was, of course, about radical cost reduction. It's not about just few percent. It's about real cost reduction. I will skip all function analysis, flow analysis, everything. Let's go to cause and effect chain analysis. Exactly. We started from very beginning, excessive cost of the coffee bag, right? And if you ask why, because you know we have excessive amount of coffee there. Why? Because we don't use this coffee sufficiently, right? We do not extract all aroma substances effectively. Why? Actually, we identified two interesting causes. One cause is because, three actually, because a temperature of water isn't sufficient. Because you know, the hot water extracts much better than cold water. Second cause, presence of calcium and magnesium ions. You know, if water is hard water cannot extract. It is a kind of chemical fact. Hard water doesn't extract aroma substances effectively. And a third cause was because we don't have effective water circulation through paper, right? And here we can identify one key disadvantage, presence of these ions in water, because should I ask why do we have these ions in the water? It is just natural fact, right? It is a key disadvantage. Second key disadvantage, why do we have insufficient water circulation? Because pores in paper are too small. Should I ask question why they are too small? Yes, I can. I just don't have place on this slide. Tell me why pores are too small. It's obvious. If you make large pores, you will lose coffee particles. Like, it is a very good contradiction, right? Pores should be large to conduct water and should be small to stop particles inside. And the third problem was about water temperature. Why, guys? We add boiling water in our cap, right? Why is it cold? Because you know what? We just cool water very fast, too fast. Why? Because we just mix water like that. Why do we do it? Oops. Because we have insufficient coffee extraction. We call this situation vicious circle. Right? Can you see? And what is good about such vicious circle? If you break it somehow, you will get extra positive result for free. For example, let's address the problem with calcium and magnesium ions, and we will improve coffee extraction. In this case, it will be not necessary to move it like that. You will not mix and cool the water. Water will be hot, and coffee extraction will be improved even more. Do you understand? And if you have key disadvantages, after that you can solve your problems. For example, here we used function-oriented search and solved the problem. It was not necessary to invent anything. We just asked expert how to extract ions from hot water. And expert chemist recommended us to use so-called ionides. You know what ionides are? It's kind of resin which can absorb ions from water. And you know, we asked, oh, probably it's very expensive. No, it's dirt cheap. Probably it is not FDA approved. No, people use these ionides to treat water. And you know, incidentally, color of this resin is a dark brown. And our solution was to replace extremely expensive ground coffee with dirt cheap ionides. And that's it. Do you understand effectiveness of the tool? Can you see how it works, right? Good. What about trimming? This is definition of trimming. Trimming is a technique which allows us to eliminate components from the system, maintaining or even improving functionality. Actually, as an illustration, I was going to use a picture from, you know, famous cartoon Flintstone family about this Stone Age people, and they just use cars with no engine. They just use their legs, right? And I found even better, you know, picture like, guys, we have no engine, but car is still moving, right? Because we delegated function to super system component. Some example, we performed many years ago for Xerox. You know, they produce toner for printers and for copy machines. And it was necessary to fill out some tubes with this toner. And toner is very kind of unpleasant substance. It is very sticky, you know, it can agglomerate. That is why productivity of this hopper was very, very insufficient. And they asked us to reduce cost dramatically. It means it was necessary to increase productivity of the system. And we found out that actually here we have so-called auger, you know, like a screw which pushes this toner down, but it works very, very slowly, because if you increase speed, immediately you will just compact this toner and destroy it completely. And we asked ourselves, what is the best auger? No auger, right? No auger, no problems, agree? But the question is, who is going to transport a toner? And we decided to delegate this function to super system component, to gravity. It is necessary, and build cause and effect chain, it is necessary to reduce viscosity of this toner. How to reduce viscosity of powder? We decided to use vibration. If you apply vibration, it behaves like a liquid. And you just open it, and that's it. When we demonstrated it to experts, they, okay, show us. Guys, step back. Oh, don't worry. Okay, we open it, boom, and they were like Afro-American, you know. It was extremely fast, because toner was like a water. No auger, no problems, right? Trimming. And we just made a real machine. We delivered it to the company, and it works there. After that, they just made more machines, and we protected the solution with number of patents. Clear? Do you understand idea of trimming? You eliminate component, and your system will become better. Another example, a mixer for peanut butter. You know, people are crazy about the weight, and company decided to offer them, please hear me out, low-fat peanut butter. Low-fat butter. How to do it? They decided just to add some neutral substances like starch, corn syrup, and formally it is low-fat, right? But try to mix very viscous butter with powders. It is very, very difficult. That is why they had 3 mixers with different action principles, and gradually they very slowly mixed this butter with these powders. And of course, we decided to apply trimming. It was too expensive, too slow. We just trimmed all mixers except of one, and decided to delegate all functions to this one mixer. And once again, would you tell me how to dramatically reduce viscosity of butter just to mix it effectively? The same solution, vibration. And we just applied vibration, and butter was, when I first time we made experiment, just on the table. They put the butter, this butter, and used this vibrating device. And butter became like a water. Even surface became like, very bright, because no this rough surface. It was like a water, and all powder was in the salt, and that's it. And we dramatically reduced cost, we increased productivity, but we trimmed components. Can you see? Less component, better system. Feature transfer. Many years ago, we performed a project for a company from Finland. Finland is a very small country, European country. They have no natural resources, and the only natural resource they have is a peat. This peat is a soil of swamp, which could be used as a fuel. It is flammable. What they do, they just, dry these swamps. And after that, they plow these swamps, but plow like that, very, very shallow. And this just peat dries. It's very just north country. That is why just few days, sunny days. And somehow they dry this peat. And after that, it is necessary to collect this peat. And for this purpose, they use like a bulldozer. Bulldozer, it's the blade is small, but very, very wide. It's 19-meter wide. But this, it is not like that, but like that, right? That is why they collect 17 meters, and they make like a ridge, ridge of this dry peat. And after that, they just collect this peat. But the problem is, remember, it is a swamp. It is not like flat, right? It's like that. And if you have this blade, if you put it down, you will cut wet peat and mix it with dry, but price of the peat depends on humidity. More humid, less price, that's it. But if you put your blade up, you will collect only dry peat, but you will lose a lot of peat on the field. They didn't have a good solution. They decided to solve it using organizational approach. They teach the drivers during 2 years, like military pilots. And these super trained people have to somehow control these blades to collect only dry peat. Result is awful, guys. Just about 25% dry peat they lose on the field, and they cut a lot of wet peat. Do you understand the problem? Of course, we could just solve it as a regular problem, but instead we decided to apply feature transfer. Let's try to identify a system which is extremely selective, which can collect only dry powder and will not touch heavy wet peat. Would you suggest me such system? Which is very selective, which will collect only powder. Vacuum cleaner. Exactly, vacuum cleaner by definition can collect only this dry powder. And we thought that it is just artificial, theoretical system. You will not believe me. These guys developed this system. Look. They developed this monster, this vacuum cleaner, which could collect. It's very selective, believe me. It collects only dry peat. But what about productivity? Remember, our bulldozer is 17 meters. Here we have, I don't know, 2 meters. What about speed? It is very slow. And also, what about energy consumption? I guess it consumes more energy than collect, right? Oh, we have two systems, right, with alternative advantages and disadvantages. Now, of course, a base system will be our. It is very simple, very simple and inexpensive, right? And we need to understand why this vacuum cleaner is so selective. What feature allows the system to be so selective? If you think about it, we can say that why it collects only dry peat? Because it applies airflow, right? Or the airflow is a feature to be transferred to our blade, right? Okay, this is our base system. With this airflow, which should be transferred here. And now we have a small adaptation problem. How to use airflow together with blade to collect all dry peat and don't touch wet peat. And we developed this solution. Look, it is just hollow blade. And this blade has openings here, right? And we pump compressed air here, right? And this compressed air works as a like air cushioner, right? And it pushes all dry peat, collects all dry peat, right? And that's it. We do not cut any wet peat, and we collect all dry peat. And this solution costs nothing, right? Because a small compressor, and that's it. And of course, we also added some holes here. And air goes here. Air works as a lubricant. It reduces friction between peat and blade. In this case, we can reduce angle. If you reduce angle, you collect more peat. Can you see? We dramatically increased productivity, and cost is nothing. Do you understand what is feature transfer? Very powerful tool. And function-oriented search, our preferable tool. This is just algorithm how to do it. We just formulate our problem in form of function. We generalize this function. After that, we identify leading area, replace general terminology to specific terminology. And after we'll go to Google, and Google will find your solution. Example. We did it many years ago for Motorola company. You know, they produced, it's microchip production, right? There is a wafer, so-called wafer. It's a large disk of pure silicon, crystal silicon. And they need to deposit so-called photoresist. Photoresist is like a polymer viscous liquid. And after that, using mask, they just polymerize this photoresist and so on and so forth. But now we are talking about deposition of photoresist. They just rotate the disk, add some liquid, and liquid just distribute. But because of some reasons, sometimes in this liquid, some bubbles emerge. And if you have bubble, you need to dispose of this wafer. And they had no idea how to get rid of bubbles, because sometimes they had bubbles, sometimes not. No idea. And it was necessary to solve this problem. And we decided, no, we will not solve this problem. We will try to find existing solution using function-oriented search. Would you tell me what could be a leading area for function to control bubbles in a liquid? Who are the best experts of bubbles in a liquid? Just think about. Who? Of course, just sparkling water. But yeah, you're right. But actually, we found just very close for this sparkling water, champagne industry. Guys, it is very old industry, and they know everything about bubbles. Because sometimes they need to prevent bubbles, and sometimes they need to stimulate bubbles. And we went and asked them, guys, how do you control bubbles? How to prevent bubbles? And you know, solution was very, very simple. Idea is, if you have a liquid with dissolved gas, and it moves smoothly without any turbulence, there will be no bubbles. But in case of turbulence, you immediately release these bubbles. Why do we have turbulence? Two typical reasons. Why, if you change direction of the flow, and second, if you change cross-section of the flow. That is why solution is very simple. Keep the pipe straight, just no changing, no elbows, and avoid this stuff. After that, we looked to the existing system, and we found out that they use so-called ball, this type of valve. And look, in this valve, by definition, there is a changing of the flow, plus there is a changing of a cross-section. And this valve is a very good source of bubbles. And we recommended, okay, let's use this type of valves. In this case, when it is open, it is straight and no cross-section variations. Look, and that's it. Bubbles disappear. Look, what we are talking about, it's super high-tech industry, right? And where have we found solution? In champagne industry, 300 years ago was invented, right? Can you see? Not necessarily you will find solution in some high-tech industry. No, sometimes people in such very narrow niches have very good solutions. Do you understand the effectiveness of cause and effect chain, or of function-oriented search? And another example, it was about very different area, about emergency room of the hospital. You know, there every second is vitally important. And sometimes they just lose patients because they couldn't perform all operations fast enough, right? And they didn't know what to do, how to accelerate the process. And how? We decided to apply function-oriented search. The question is, who are the best experts of very fast actions? And we found such the interesting area is Formula One vehicles. You know, they used to make so-called pit stops. They need to replace wheels, right? But guys, time is ticking. Every second, and every second costs millions of dollars of price, right? That is why they developed great technique how to make everything parallel. You know, each person performs only one function, very specific function, but all functions are performed in parallel. And we just transferred this technology to the hospital, this emergency room. And actually, look, instead of 3 or 4 hours, it was in some cases, we can reduce time to 8-10 minutes. Would you imagine this result? How many people can we save using this method? And remember, we didn't invent. We just transferred existing solution. Well, conclusions. Our methodology is extremely powerful and could be successfully applied to radical cost reduction of practically any object. We can improve products, like piece of metal. We can improve technological process, because it is technological process. And we can improve service, because service is also kind of technological process, right? Now, what questions do you have about application of TRIZ for cost reduction?
The example that you showed about bubbles.
Which one?
Example that you showed about bubbles.
Uh-huh.
Sometimes the bubble do appear after the baking operation.
Yeah, I know, but we were not asked. Do you understand the question? Sometimes bubbles emerge not when we deposit photoresist, but when we just polymerize it, right? We were not asked about it. Actually, in fact, we identified deep causes of the problem, because this cause, this turbulence, was like on the cause on the surface. We identified much deeper cause, and we found way how to, because why do we have bubbles? Because liquid dissolves gas. And if we would prevent this dissolving, we could prevent bubbles by definition. And we found causes why a liquid dissolves this gas, and we prevented it. But it is a very long story. Okay? Other questions? Yeah, go ahead.
I represent Capgemini, so basically a service industry and labor intensive. Have you in your consulting experiences understood if there are some specific levers which affect
Yeah.
labor intensive?
Yeah, right. Guys, when we build function model, we include people as a components. And after that, we can trim them. We are not going to kill them. We just, we eliminate people from the picture and delegate the function to other people or to other engineering systems. And this way, we can dramatically reduce labor cost without radical modification of the system. But sometimes we have problems because people are people. For example, I remember at General Electric, there was kind of process, technological process of molding. And there were a number of operations, and there was a group of people, and each person was kind of responsible for each operation. And we just decided to make trimming, and we trimmed few operations. And they just presented results. Look how now we have new process. But only one guy say, wait a second. But what am I going to do? If we trim the operation, I am responsible about. And he was, oops. That is why actually methodology works, but we should be a little bit careful. But you know what? We are not going to fire people. We just assign them another job. Yeah, please. Go ahead. Go ahead.
I think, yeah. This is Lokesh from Mantra. We are a consulting firm, help companies driving innovation. What we are seeing, the cost saving, actually, there are many methods, people use Six Sigma or value engineering. There's so many methods which goes in the organization. But actually, people already, they reach the level of saturation, the pushing themselves, actually. It's very hard to really even get some 10% to 20% saving, actually. So by the time you deploy the 10% saving or 20% saving, I think you remain with nothing because the lead time for implementation takes longer time. So the new mantra should be something like, the bringing cost to zero, how to really bring cost to zero. All these inventors, the people who are working in the organization, they set the limits low, actually. They don't have aspirational goal to achieve something remarkably high benefit by eliminating something. We always think about eliminating the waste. Can you really...
Okay, what is your question?
Question is basically how to bring cost to zero, going away from cost reduction. That is what is my thought process.
Actually, look, if you need to reduce your cost to 5%, you don't need to apply our TRIZ magic. Just simple lean or Kaizen just can help you, just reduce some waste, just reorganize a little bit. If you need to reduce cost order of magnitude 10 times, 5 times, in this case, our methodology is inevitable because can you see radical trimming, something changed completely, and system will become much, much better. The most difficult situation, if you need to reduce cost about 25%. In this case, from one point of view, some radical modifications are not allowed. But from another point of view, some minor polishing doesn't work well. For us, it is the most difficult project, but we know how to do it. It is necessary to adjust because beauty of our methodology, particularly trimming, it is adjustable from zero if there is no trimming to most radical. In few cases, we observed situations when we trimmed entire system. Just entire system disappeared. okay? But also we could do something in between. Just one component, two components, three components, okay? This way we can adjust and get achieve this goal to reduce cost, for example, this 20% without radical modification of the system. And once again, I believe that TRIZ is very complementary to other methods, particularly for Six Sigma. They just can get married very effectively. For example, at General Electric, with just very good kind of connection between TRIZ and Six Sigma. It works well. And I believe it could work together with Lean also. Okay.
I'm Kulkarni from Bajaj Auto.
Yeah.
Sometimes the interesting example what you showed about peat that is getting collected using the compressed air. But sometimes such simple solutions really deployable but cannot be used because of environmental restrictions by the land of law. For example, if we talk about cement or some chemical to be collected in same way, where we can deploy this, but there is a chances of the particulate spreading into air. So there we have to use vacuum
Yeah,
or
I
some
understand.
other method. So how TRIZ addresses such kind of
guys,
balance?
I can comment. Guys, a modern technique, actually, I mean, that our civilization can solve practically any problem. Well, probably we cannot develop anti-gravitator now, right? But all other problems could be solved. Why do we have our problems? Because there are some solutions, but they are not allowed due to some additional requirements. For example, oh yeah, we can just use compressed air to transport cement. We will generate a lot of dust. It is environmentally not friendly. It is not allowed. It is all the time. Yes, we have solutions, but we cannot use them. And our methodology allows us, it is a kind of contradiction. If I do this way, I will transport cement but contaminate environment, right? And we know how to resolve contradictions. We know how to make everything. It is our kind of core competence. We are great in this area. And I have a lot of examples when we did something that was allowed. Okay, yeah. Yeah.
Being used in service sector versus the technological problem identification. For example, you talked about the hospital, the ICU rate, right? That's kind of addressing the service sector, the cost reduction in the service sector versus some kind of an engineering problems. So how is it like? What is the success rates and how well is it studied in the service sector?
You know what? Service, it is a special type of technology. A very typical technological process, how we cook, right? There are a number of operations. You need to take product from a refrigerator, you need to cut it, you need to boil it, right? It is operation. Can you see operations? But service is also operation. You need to, find the customer, just inform the customer, do something, and so on. Operation by operation. And we can apply the same approaches for this technological process. For example, recently we completed a large project for a large bank, Russian bank. It had a problem with some, there is a process how to provide a loan. You're going to take a loan, and it is a process, the bank process you, just, interacts with you somehow to get a loan. And this area has a lot of restrictions from legal point of view, right? We could do it very fast and effective, but it is not allowed, this is not allowed. But if you use just all legal steps, it will be too bulky, and people just drop the process in the middle, and they don't take a loan. And we found ways how, without breaking the law, how to make the process much faster, easier for the person, and easier for bank. Okay. Also, we performed one project for some internet bookstore. you know, this bookstore just used to sell books through internet, and they had an effective method of processing. And it's a service, right? Number of operations. And we just trimmed some operations. We made the process much more compact and more effective. Okay?
I have a short question. Maybe it's connected to the colleague from here. Also, in some cases, you are already reached to the minimum level of cost for, and there it's very difficult. But you have the possibilities, techniques still to go for this few percentage down. And here, if there is a, how do you look into the balance for the cost and quality? Because sometimes it's important that there is no option for the quality. For example, for some implants in medical, if there is a specific material, till the time you have the latest material and biocompatible, and so here if you want to reduce the cost, so that would be very challenging, and till you have some invention, real invention to come into.
Okay, I will try to answer this question. Guys, you have a product or process, doesn't matter. You reduce cost, that's it, right? Cost is very low. What else can we do? How else can we improve the system? But guys, people don't care about cost per se. They care about you know, functionality over cost. What you have for this price. And if you cannot reduce cost anymore, you can add some functionality, and even you can afford to increase cost, and people will pay because you offer them much better functionality. And for this purpose, we have special tool. Remember, I told you from very beginning, MPV, these main parameters of value. But guys, it doesn't mean that you have existing MPVs and you try to satisfy them better. You can add more MPVs. For example, you know, I once used example, you produce cars, and you produce cars, and you compete, right? And you cannot reduce cost because costs are reasonable now. What can we do? What if you add new feature to your car, and your car will fly? It will not fly long, just a few hundred meters. Not very high, just few meters. It will consume tons of fuel. It will be ugly, right? But no one else can offer this feature. All people stay in traffic, but your car just jumped through it. Look, it is more expensive. It has number of disadvantages, but people still buy it and they're very happy with it. And this approach, we add more MPVs, and even we satisfy them on the relatively low level, people will be very happy. And we have special technique how to do it. Okay, thank you.